Good afternoon, everyone, and thanks for joining us today for the Data Science Masterclass, which is a series of workshops by experts around various aspects of AI and data science. Today's masterclass is on customer data management with data science, powered by HP Inc. India. I'm Anil Chopra, VP Research and Consulting at CyberMedia Research, and your host for today's session. We do have a very exciting lineup of sessions for you today. We'll start with the masterclass on how do you really manage customer data with AI and data science. This would be followed by a session around innovations and systems that you really need to do justice to your data science projects. And before we start, just do note that for the duration of the sessions, all participants will be in listen-only mode. You can, however, keep sending us your questions through the chat window. We'll do a Q&A session at the end of the webinar. And if you have asked some really good questions, you might be the lucky winner of an Amazon gift voucher worth 500 rupees. So please pay attention and keep posting your questions. To briefly set the context for today's session, as we all know that with increasing digitalization, the resultant data that is being produced is at an unprecedented speed. Digital transformation that was supposed to happen 5 years down the line had to be done immediately, thanks to the pandemic. And as a result, digitalization increased, and the need for data actually went up like anything. And it's no wonder then that data is being termed as a new global currency. And you need to be able to derive value from this data. And by doing that, it brings up so many different opportunities that can improve your business outcomes. It can help improve your customer support. It can enhance relationship with your customer. In other words, it helps you understand your customer in a much, much better way. And moreover, what's more is that, traditional data analytics tools that you normally would use to analyze data, they're just not enough. Considering the speed and the volume at which it's really, really growing. And moreover, it's coming from multiple channels. It's no longer just, structured DBs that we're talking about. Today, data is unstructured. There's so much of it coming from so many different channels. So you actually need, data science tools that can actually, make sense of all this data that is coming in from so many different places. Of course, this is easier said than done. There are so many questions that come to mind. Where do you really start? What sort of skills are required to handle, customer management related data science projects? How do you really use data science to understand your customers, for your specific industry? Because, it can vary from industry to industry. And, some of the technologies and tools that are required to handle data science projects for customer management. To answer some of these questions, that's what our first masterclass is all about today. It's my pleasure to introduce and welcome our expert speaker, Anish Nohria, who is the Director of Data Science at American Express. Can we please have Anish on the center, please? Welcome, Anish, and thanks for joining us today. Before I hand it over to you, please allow me to give a brief introduction about you to our attendees. Anish is a business leader with over 22 years of global and diverse experience, in product management of lending products and developing payment solutions, risk management, data science and analytics, and strategic consulting. An MBA from IIM Ahmedabad, Anish has experience working with banking, financial services, and IT industries with demonstrated ability for providing innovative business solutions, granted patent certificate, and creating economic value using advanced decision analytics, statistical modeling, and microsegmentation. Welcome once again, Anish. Thank you so much for joining us today. And I now hand it over to you.
Thank you. Thank you so much, Anil. I think that was a very, very humbling introduction. I didn't even realize that so much time has passed since I joined American Express and since I started working in data field. Allow me to share my screen before I start. I hope my screen is visible, Anil.
Yes, Anish, it's visible.
Okay. So let's start with the topic. I think you laid a very good context in terms of what is happening in the wider world, right? And that is independent of the industry. The humongous amount of data being created because of pandemic, a lot of digitization being happening, and the role of data becoming more and more important, right? I think there is no two view on that. What we're gonna do today in the next 20 to 30 minutes is sharing some of the perspectives from a practitioner's mindset, right? I'm not going to spend a lot of time on the techniques and tools which keep on changing. And I've seen this industry evolving. When I joined this industry, sometimes our programs used to take overnight to run, right? We used to submit our data queries or our analytical queries before going home. And next day we used to get the relevant data. Now all these things happen in seconds, right? So the infrastructure, the tools, the techniques keep on evolving. That will always happen. So my focus today is not going to be more on how do we do data science, but what exactly is data science, how it adds value, and some of the perspectives which I have gained over the years in terms of data science, right? The second part, which is the key, is the customer management, right? Why data science is important in customer management? First of all, what is customer management? And we'll spend some time there, right? And what all you can do in terms of data science in managing your customers better, right? Those are the three things I want to focus. And as you said, Anil, we will really appreciate the questions from the audience, which we'll take in the end, right? So what is data science, right? Very simply, it is actually the field of bringing out insights from data using scientific techniques, right? And as I said, these techniques are evolving, have evolved, become better, and will keep on becoming better, right? But broadly, within data science, we categorize problem solving into two areas, right? One is hypothesis driven, the other is data driven. Now, what is the difference between these two techniques or approaches, right? More than the techniques, these are approaches. Hypothesis driven is, I have a problem to solve for my business. I may be a business leader in any industry. Now, to solve that problem, what kind of data I need, right? Take, for example, right? Let's say I'm managing a portfolio. I'm in insurance or I'm in a bank. And I see a lot of my customers attriting in the last 3 months, right? So this is a problem in my hand. Now, what do I need in terms of data to answer the question why my customers are attriting? Do I need to look for competition data? What kind of competitor products they are picking up? Do I need to look what kind of offers were being sent to them in the last 3 to 6 months on which they were not responding? Do I need to look at some of the call data because these customers may be calling me and I'm failing to read the signals from these customers, right? So what do I need, right? Is the hypothesis driven set of approach, right? The second approach is data driven. You say, I have some data. Now, what problems I can solve with it? A very typical example is, think about it like, a lot of our e-commerce players like Amazon. Amazon has a lot of data on our purchase history, right? Most of us use Amazon, so it's very easy to understand. So Amazon knows in the last 12 months, these are the books I have bought. These are the electronic gadgets I have bought. These are the, maybe retail products I have bought. Now, if I am the Amazon business manager, I have this data now. What do I do with this data? What is the interesting problem I can solve with this data? And as we know, what does Amazon do, right? They say, okay, if you have bought this thing, you may be interested in some other product. So they're trying to figure out clusters of products which I may be interested in. So they're trying to cross-sell to me. They are trying to recommend some products to me, right? And so on, right? So this is the other set of problems which can be solved with data. What is the evolution of data science, right? So if you look at it, data science seems to be a new field. When I say seems to be, probably we are hearing more and more of things like data science, machine learning, AI over the last 5 to 6 years. But if you go deeper, data science is at least 60 years old. There was a paper in 1962 written by John Turkey called future of data analysis. When he figured out that because of increasing consumption in US economy, a lot of retail data is being generated and a lot of people have started using that data to market to customers. And then he wrote a paper which became kind of a flagship paper on data analysis or data science in 1960s. Think this is the kind of data being generated. Obviously, the digital world, the kind of unstructured data which Anil you referred to was not there at all in the picture. But the principles were the same, that a lot of data was being generated. How do companies use that data to market better to their customers, right? And obviously, over the last 60 years, this field has evolved. We have more unstructured data. We have social media data. We have much more computing power to analyze that data, which means our ability to generate insights out of that data has become much, much more than probably it was 20 years back, right? Now, when we see the evolution of data science, it is not only in terms of business world. In fact, business world is more like a tertiary user of some of the techniques which came out to analyze data. The foundations of data science or the foundation of data analysis was actually laid in other science fields, primarily astronomy, medical science, where they used to analyze a lot of data to either predict the course of the disease will take or the course of celestial objects which are there in the universe, how they will go about. So they were using a lot of data science, right? 60 years back. But then businesses figured out, right, starting from retail industry to finance industry, that, hey, you know what? I can increase my profitability by mining this data, right? And that's how the data science field has evolved over the years. Okay, so I just wanted to touch upon, very briefly, this is a topic in itself in terms of how data science has evolved. Moving on. As I said, I'm also very interested in sharing my perspective in terms of, what data science is and what data science is not, right? Definitely, there is humongous value in data, right? But my view is we must be wary of how much actionable insights can be generated and, acted upon. So I just put a, very famous cartoon strip from Bill Burke, So this gentleman has got some recommendation for a base jump basis his past history, right? Another question is, there's a lot of data available out there. There's a lot of techniques which are there and techniques are becoming better. There's a lot of suggestions or recommendations a data scientist or the analytical department will bring to the business. But we have to see whether all the insights are actionable. Even if they are actionable, will it actually lead to enhanced business, right? And that comes with a lot of, real practice, real management of the business, right? Just data in itself is not sufficient, or insights generated from data, in itself is not sufficient, right? And we have to be very, very mindful of that. And this is something which I can share from my own experience, right? And when I see especially a lot of young people coming with very, very good education background, coming with a lot of data analysis, but not able to figure out, how exactly we will use them, right? So as the field has evolved, I also wanted to touch upon, what are the kind of skill sets which are required for data science projects, right? So if you see this Venn diagram touches upon 3 sets of skills, right? If you look at the right-hand side, let's start from the right-hand side. On the data analytical skills, right? There is data analysis software, there DBMS, then we know about tools like Power BI, Tableau, etc., right? So these are tools which are more descriptive in nature. You give me the data, I will lay out how the data looks like, right? But obviously, I also need to know some programming, right? Python being the most prevalent programming skill as of today, right? Obviously, there are other skills required like SQL for pulling data, R, Java, right? Statistics is a must, right? Then problem solving or your ability to, understand the business problem. Storytelling, right? Storytelling comes slightly later in the day when you have to sell your product or your solution to senior management, right? But then what are the skills which have come probably in the last 5 to 7 years, which are purely data science related skills, right? So these are the overlapping skills which we just spoke of. Then what are the pure data science skills? From pure data science skills is a lot of knowledge of machine learning, right? And these days, if you look at the academics, I see probably every other course being offered either through MOOC courses or in colleges, right, is on machine learning, right? Software development, when you have to develop a system from end to end. And then how do you manage big data, right? In our times, when I started off, probably most of the data used to come on a disk, right? Now you need terabytes of space to manage big data. And for that, you need to know tools like Hadoop, right? And algorithm development, when we say algorithm development, there are better and better techniques to create data science solutions, mostly modeling solutions, right? Whether it is NLP, whether it is boosting, bragging, what exactly you need probably has a technique at the back, right? So you need to learn those kind of skills to become a complete data scientist. Okay, let's move. Data science life cycle, right? And this is one of my favorite pages, and I'll tell you the reason, right? Let's start from how does a solution using data is created. The first step, which I've highlighted, is the business understanding. If we don't know what we are solving for, even with the best of technique, with the best of computer science knowledge, we will end up solving the wrong problem, right? So understand from a business leader's perspective, what is the problem he or she has, I think is the core skill a data scientist needs to have. Then comes the more harder aspects like collecting data or, kind of cleaning the data using certain tools. I prepare the data, and there are a lot of automated tools available for these two steps, right? Then I do some basic exploratory data analysis through ranks and plots and other mechanisms to figure out what makes sense for me. I can start with maybe, let's say, 5,000 variables for a solution, but my solution may actually end up having only 30 or 40 variables, right? How do I do all those analysis to ensure that I get the best of variables for my analysis? And then you do modeling, right? You can do supervised learning models, you can do unsupervised learning models, and so on, right? Model evaluation and model deployment, these are more, so model evaluation, I would say, is more related to how good my solution is, right? And you need to do it on a continuous basis, right? And in industries like banking, there's also a lot of governance around model evaluation, right? In the model deployment, it's more around the systems we have in place to deploy those models real time, right? Let's look at examples of things we use, right? Maybe let's think of Uber, right? When we book from point A to point B, it throws me some live price, right? Let's say if I want to go from Gurgaon to Delhi, the 300 rupees, right? And after 10 minutes, it will say 310, right? What it is doing, it is using some information to throw the price at you, right? It's a real-time model deployment, right? At work, right? And then where does it closes? It again closes at business understanding. And why is it so? Why is it a circle? Because if my model is not working properly, if my model is not able to derive the business results for which the model or the data science solution was created, then I have to ask myself, is my science not correct? Which means, could I have developed a better model? Which means there's a difference between my actual behavior and my predicted behavior. Or did I model something wrong? Which means, did I understand the business problem, right? And for that, have I understood how does my sales and marketing work? Have I understood how does my operations actually work? I'm a data scientist, but I need to understand that. Have I understood even, let's say, if I'm creating some solution from customer management perspective, customer retention perspective, which we'll speak in the next few slides, have I even understood how does my call center work? When the call comes to the call center for some customer complaint, how does it flow, right? If I don't understand those things, more often than not, I will end up creating a beautiful technical solution, but not a very relevant business solution, right? So that is why the core of the whole data science lifecycle is and will remain understanding what I'm solving for. This is true irrespective of the industry, right? This is true irrespective of the level of data science being leveraged in a particular company, right? Some companies obviously are much higher in terms of the curve where they use data science, and some companies are evolving, right? They just started, right? That's irrespective of that. So what is customer management? So these were the few pages we spoke about, in terms of data science and some of the perspectives which I have as a practitioner. What is customer management and why customer management is important? So it's very intuitive, right? I need to know who is my customer. Do I understand the customer's needs? How I'm engaging with the customer, right? Can I cross-sell something to the customer? And if yes, how? How do I retain the customer? These are all elements of managing the customer. The important point is why we are so much interested in customer management. Why this whole webinar on managing the customer? See, the point is, as a business, the key driver is profitability. All the businesses are trying to maximize their profit. And how do you maximize your profit? By getting more revenue from the customers. But there is another angle to it. All the businesses are also trying to get new customers, right? What we call as acquisition or acquiring new customers. Acquiring new customers is a very expensive proposition for any business, especially as the market matures and the competition in that particular segment becomes stiff. The cost of acquisition or the cost of getting a customer through the door, a new customer through the door, becomes higher and higher, right? But if you spend the same amount of money in managing your existing customers better, by understanding them better, by figuring out when and how I can cross-sell to them, when I see some signals of these customers showing restlessness and so they can attract, right? If I spend that amount of money or budget in managing my customers through data science tools, I am much better off as a business. And that is the whole reason there is a lot of focus in any industry to manage the customers. Obviously, the focus is going to be to acquire customers also, but the return on customers well, right? Because it's like, say, you lose a customer, especially a well-spending customer, you basically probably lose a lot of money, right? We spoke about it in the last slide a little bit. I just wanted to give you a comprehensive view here in terms of how customer management lifecycle looks like. It starts from initiation to maintaining and to termination. And all the points data science is being used these days, especially in industries where we see more matured efforts in terms of data science. So whether you evaluate the customer, you acquire the customer, recovery is basically when you go back, somebody has attrited and you run programs to get those customers back. You evaluate the customer in terms of maintaining them. I've highlighted two areas, which is customer retention and upskilling, cross-selling out of all these things. The reason being, these are two areas where if you use the data science in the right manner, right, you as a business leader will end up making a lot more money for your department or for your business, right? Customer retention through data science actually has been perfected to an extent by a lot of industries, because there are short signals through data where customers will start showing signs of disengagement, right? Whether through their spend behavior, whether through their social media comments or kind of behavior or the imprint they leave on social media, or you can read information in terms of what is the activity they are doing with their competition, right? So a lot of signals which the customer gives, basis which you can use your data science to engage them much before they actually, act right? And similarly, upskilling and cross-selling. Each customer evolves through his or her lifetime. So needs change. Let's say if somebody acquires a customer today on product A in the product line strategy of a company, after 5 years, that customer is actually ready for the higher level product. But are you catching that customer at the right moment with the right offer? Because that customer has been your customer for the last 5 years. Right? So all those things, if data science is leveraged, can be managed in a much better way, right? Perspective, some of the data science topics where we see customer management being done through data science. The first one is customer segmentation. I can segment my customers in many ways, basis geography, basis demographics, basis the behavior in terms of whether they are low spenders, high spenders, and so on. Right? Then there is predictive analytics. Predictive analytics basically tells what this customer will do maybe 6 months down the line or 12 months down the line, right? And again, these set of predictive analytics helps the business to design the products and the programs, right, around the customers much better. Because they know, I can see from predictive analytics that this set of customers or this set of markets are going to behave in a particular way, right? Then personalization. I think there are a lot of examples around personalization, especially on the e-commerce side, where we get to the last degree offers from players like Amazon or Netflix and so on, saying, this is what your past history has been. So we are sending you an offer which is commensurate to your own past history, right? What is trending these days a lot, and Anil, you also refer to it, is social media and sentiment analysis, right? And now why it is becoming important, though this is unstructured data, the signals from this data are very difficult to read, but are very strong, right? Because when people choose and put something on social media, that's out of a lot of kind of conviction, right? And if you're able to read certain signals in a systematic way from social media feeds, it helps you as a business to design your customer management strategies around that. Let's say somebody uses your product and he or she is either happy or not happy by using that product, and he or she posts it on, let's say, Instagram or Twitter, right? And if you pick those signals in the right way, you can actually improve your customer management. Then comes the profitability framework, which is like the holy grail of putting everything together. Can I reach a customer level profitability number saying, if, let's say, Anil is my customer and this is his behavior with me, this is the profit I will make if Anil continues to be my customer for the next 12 months, right? And basis that, all my customer management strategies can be, fine-tuned. I can send relevant offers. I can prioritize that customer in the treatment. I can do many things, depending upon the business or industry I am in, right? And where all the customer management strategies are being used, I think that is probably think of any industry, right? Retail, it's e-commerce, entertainment, food delivery, finance, banks use a lot of data science for customer management. Healthcare, which is again, it is evolving field. There's a lot of privacy concerns on the healthcare side, but healthcare also is using a lot of data for managing their customers better. Quick case studies in terms of Amazon, Netflix, and Zomato, how these three leaders are using data science for managing their customers. Amazon, I think we kind of alluded to, right? They use a lot of purchase data to fine tune the offers, to recommend you certain other product categories, to send you offers which are very relevant and personalized, right? Netflix started with the recommendation game, right? They ran a contest probably 10, 12 years back, wherein they said, we will give $1 million to somebody. They make their database public, who can come out with the best algorithm to recommend movies, right? And that's where I think the whole recommendation game started. Zomato, I think Zomato and companies like Zomato, even Swiggy, are using the data of orders in a very systematic way to figure out where are the clusters, what kind of offers in terms of cuisine are coming, what is the average delivery time, is there an opportunity to create some kitchens. They are even going to that extent that can I recommend to entrepreneurs that there is an opportunity to create a particular kind of kitchen in that area, because I see orders, but the delivery time is higher because there are no restaurant and so on, right? So they are doing like kind of a lot of stuff with the data to manage their customers. Some additional thoughts. I think it starts with basically I'm ending with where I started from, that data science is absolutely powerful, absolutely necessary in customer management, but there is a limitation in terms of what kind of actionable insights we derive. We have to be very clear about the business problem we are solving for. There is a role of intuitive decision making, especially when you wear a business leader's hat, right? I cannot run everything with data science. Data science is powerful, but I can't run everything with data science, especially when I'm solving customers' problems, right? So there is a lot more to data science, more to solving customers' problem than data science, though data science is very powerful, right? And it involves some kind of experiential decision making. Sometimes it involves a more humanistic approach to manage customers and so on, right? So we shouldn't forget about it, right? While data becomes powerful by the day, right? And what do I believe is going to happen in the next few years? I think data is not going to become less. Data is going to become more and more. So some of the futuristic trends would be, how do you manage such large amount of data, right? So there are trends in terms of managing that data on the cloud. That is one. NLP is coming in a big way, mostly because of unstructured data, social media data. Right? That is one. And the third thing is, there's a lot of data being collected by the new this thing of Internet of Things, right? And how do you marry all that data to drive even better insights on your customers, right? So these are some of the things which I think are going to become more and more popular in the next 2 to 3 years, where people are, and in big companies are going to, invest more and more on data science.
For that, your phone needs a mobile or Wi-Fi.
Yep, that was it from my side, guys. Hope it was useful. Anil, over to you.
Yeah, thanks a lot, Anish. I think, yeah, absolutely. It was indeed a very insightful session. And I did see some questions and all coming in from the attendees. If you could just stop sharing your screen so that we can both be in the center. Yeah, thanks. Can you please show me on screen, guys? So, quite interesting, Anish. I think there are a couple of questions which I'll probably ask you at the end after the next session. So hold on to that. There are some interesting things that are coming up. For the attendees, I think I hope you found it useful on really analyzing customer data and using data science to do that. And I did see some questions from you. Some people also posted some comments and observations. But if you do have questions on those observations, please post them, so that it's clear and we can have a really decent, healthy discussion at the end. We'll take that up later on. And, but one point is that while it's great to have so many tools for data science, it's great to have so much of software. The thing is, they won't be of much value unless you have the right hardware in place, right? Unless you have the right systems in place that can actually, do justice to them, that can do the actual analyze the volume of data that is there, it won't really be of too much of use. And I believe there is quite a few innovations happening on that side. And, to tell you about those innovations, it's my pleasure to welcome our next speaker, Prerna Daga. She's the Business Development Manager for Data Science at HP. So I'd like to welcome Prerna on screen. Can we please have Prerna on screen, the admin guys? Hello, team. Prerna, can you just unmute and say hi? Because while these guys are trying to sort out something, maybe you can. Yeah.
Hello, everyone.
So welcome, Prerna. And, before I hand it over to you, just a brief introduction about Prerna. Prerna has over 9 years of, multidisciplinary experience, which cuts across business development, data science and analytics, business analysis and planning. She's an MBA with a specialization in information management and a BTech in comp science. So welcome once again, Prerna, and over to you.
Thank you. Thank you so much, Anil, for a great introduction. Hello, everyone. A very good afternoon to all of you and a very, very warm welcome. Before I begin with my presentation, I'd also like to thank Anish. Thank you so much for sharing your experience. I mean, this time I know wouldn't do justice to the entire customer management in data science, but I think it was very, very well organized presentation. Thank you so much. So I'll just share my screen. Okay. Okay. I hope you can see my screen. Okay.
Yes, it's visible, Prerna.
Okay. So, so let's get, Anil has already introduced me. I'm Business Development Manager for India markets at HPI for Data Science Solutions. The agenda for today, I'd like to take you to what is Z by HP's vision with regards to data science. What are some of the key challenges that we see in accelerating this data science journey, in the adoption of data science solutions by various enterprises and customers, and how do we approach them with our solutions? We'll also touch upon the most popular data science software tools and libraries and what do we think about it, and Z portfolio. So since we're talking a lot about Z by HP and what are workstations, I'd just like to touch upon what Anish mentioned in his presentation, right? That over the last few years, we are hearing a lot more about data science and data science use cases and how industry is really adopting it. And there's so much demand. And I think all the organizations, now we don't need to convince organizations about the real value of the data science. They already understand it, right? But what happened? What changed in the last few years? A decade ago, when I was doing my engineering, I remember I doing my final year project using neural networks. Then I don't recall we calling it deep learning or anything else, but it was simple neural networks doing fingerprint recognition. And as Anish mentioned, that the first white paper I think was published in 1962. So what has changed in the last few years that we see such a huge traction and adoption? So my take on that is that one thing that has changed is that we are getting and generating huge amounts of data, right? So the frequency of data and the velocity with which the data is coming in has increased a lot. And second thing is that the industry has also made progress in terms of equipping the data scientists and the users in making sense, in deriving insights for that data in terms of, let's talk if it is processors or, GPUs or even your machines, right? We have taken a tremendous, leap in innovation, driving across, be it GPU or CPU, so that we can derive insights from that data. Before I start with data science vision, I'd just like to tell you about when I say Z by HP, what do I mean by it, so that when we cover the presentation, we have that in back of mind. So in Z portfolio, we have some very powerful mobile workstations and desktop workstations. When I say workstations, they are high-end server-grade, machines with high computing and high processing, so that you can do a lot on your own device on edge without any external input or any external software. I'll talk about this portfolio again later once I cover about the challenges and the solutions we have. So quickly moving on to what is Z by HP's data science vision. So our vision is threefold. So first is accelerating data science workflows, right? So local compute allows data scientists, data analysts to confidently iterate over their workflows, over their models, quickly without, worrying too much about the cost or at a very predictable price, right? So that's where accelerating data science workflows comes in. The second leg of our vision is complementing and enhancing cloud infrastructure. So when we talk about powerful workstations, so people generally have this misconception that it is about replacement for cloud or trying to rip apart cloud. So that's not the case. With these machines, I think the best way to see is that we do a lot of processing that our workstations allow to do on edge, and then uploading the data which is only essential, or deploying the model which is essential on the cloud infrastructure. So we provide seamless experience on all across all the clouds, right? So if your organization is having a single cloud, or if it's a hybrid cloud approach, you'll have seamless experience with Z. And the third is faster access to critical data science tools. Once I get my system, I need a lot of tools, softwares, and libraries to get it up and running, to train my model, to retrain my model, to serve my model, to deploy my model, right? So what can we do to make you more productive in this arena, to make you more efficient in this arena? So going by that, what are some of the key challenges that we think data scientists or data users or industry is facing with respect to data science, right? The first thing is data latency, the upload that happens to the cloud, right? Massive amounts of data from the edges being produced and then being uploaded in the cloud. We are generating, terabytes and terabytes of data. So imagine how much amount of time that is going to take in taking this whole data on cloud. And then, real-time analysis is the key here. Sometimes where the use cases are of extreme critical time importance, where even a fraction of 30 seconds or 45 seconds can make a huge impact. Imagine if if the insight or if the data is coming in a little late, how much impact it can have on your system, right? So the Z solution allows for co-location of direct data capture and the analysis in the same machine. The second challenge that we see, that again with this huge amount of data that is being produced, so it takes some amount of bandwidth to take it from one machine to another machine, or from one system or in a software stack from one type of stack to another. So with CPU and GPU acceleration in Z solutions, you get a massive processing speed to handle your massive amounts of data and to complete your workflows in your workstations. Third point is security and control. With a lot of teams being involved in the organization, which has the authority over the data and working in silos, getting approvals, sometimes not having those regulations in place where you can take the data out and store it somewhere else. So this is a very good solution where you can co-locate without worrying about where your data is actually residing, right? If it is in your country, if it is somewhere else, where is the server where your data is actually residing, right? You can have it on your own system at your own desk. So that's how we address security and control. Third one is accruing costs. So as Anish, very well explained about the entire data science life cycle, that first it's business understanding, then we gather the data, and then there is training the model, analyzing and evaluating the results, then going back and again changing some hyperparameters and training the model again till we reach the stage where we are satisfied with the results, right? So to summarize this, what I want to say is data science is an empirical process, right? Here, the evidence is not verifiable against pure logic or pure theory, right? The evidence is verifiable against the experience which a domain expert comes in with, right? The evidence is verifiable against the encounter. The evidence is verifiable against the experiments that data scientists run. Now, imagine that if a data scientist is having this cost part at the back of his mind when he's running these experiments, right? He'll be afraid, he or she is going to be afraid of making those mistakes, right? And sometimes we learn more by making those mistakes. So with the upfront price that you're paying for your workstation, which probably is going to last, for next 4 or 5 years, your price is already taken care of. You have that price point in your mind. You don't have to worry about accruing costs, which are going to be there for other solutions. So so far we have talked about the challenges and the solutions. Now let's talk about the Z advantage, particularly what makes Z special, right? So Z comes, or all the Z workstations comes with the Linux and Windows pre-installed with it. So we did a lot of user research, computer scientists, business analysts, and data users. And we identified that there are a lot of data scientists who like to work upon Linux when they're working on their data science workflows. And for all their enterprise productivity tools, they like to work on Windows. So in this case, if you have one machine, so sometimes you need to reboot the machine to get to that operating system of your choice, or have 2 machines. So with Z by HP, we have WSL2, which is Windows for Subsystem Linux 2, where you can have both the operating systems in your workstations without having the need to reboot it, or without having to use 2 devices. I talked about faster access to critical data science tools, right? So these workstations come preloaded with all of these libraries and tools that you see on the screen, right from your TensorFlow, Keras, which are deep learning libraries, sklearn, which is classic machine learning library, XGBoost, PyCharm, integrated development environment, PyCharm, then Git, the distributed version, Docker, the container. So everything comes preloaded as and when you need it, you can install it on your system. So the advantage here is that first, it will save your time in downloading and installing it in your system. And the second and the most important thing is that when I'm in middle of my workflow, running my code, and suddenly there is an error, a bug, where I realize that this library is not working with the other library. So with this toolkit, that dependency or the version it is issue is taken care of. Everything is ensured that works with each other, and the version dependencies are taken care of very well. So as if you're a data scientist, we want you to focus on your work instead of worrying about the tools and the hardware which is lying behind. So instant productivity on day 1. I already spoke about WSL2 with Stack Manager. I think all these tools and libraries that are here, they are preloaded, and you can have whatever you need as per your workflows in your system. And so basically optional. It's not like that you need to have all of it in your system to work with it. I spoke about productivity, how it is going to increase the productivity and the performance, and in terms of manageability, where the inter-library or inter-tool version dependencies are already taken care of. So we have this ambassador program where whenever we have some new product or new software that we launch, we have actual team of data scientists across the globe from different organizations who work on these systems and give us the real feedback of how it is and what is their experience. So this is some of their experiences with regards to WSL2 or with regards to data science software stack manager or the Z by HP workstations. So this is the portfolio for our mobile workstations, the entry-level workstations, Firefly. And I think for data scientists, where the ultimate performance can be realized through ZBook Studio or ZBook Fury. So for those data scientists that are on the go, means mobile solutions. So this is the portfolio. And for desktop workstations, the entry level is Z2, Z4, Z6, and Z8. So when I talk about these workstations, right, they also have GPU acceleration. So in terms of CUDA cores, if I talk about Z8 can have as many as 10,000 cores with the help of, A6000 graphics card. So with that, I'd just like to touch upon this case study. So NASA was working on one of their use cases where they were having data in the format of images from sun every 1.3 seconds, right? So imagine petabytes of data, right? And if you go by traditional solutions, that's going to take probably months or years to analyze so much amount of data, right? So with the help of Z8, they were able to get it done in a 150x faster time. So this is what NASA has to say about Z8 solution, that the possibility which was earlier there in terms of time and efficiency, they were able to get it much, much faster. So these are my contact details, just in case you want to talk more about it. If you want to talk about data science, about use cases, want to know more about Z, or any of our solutions, want to evaluate any of those systems, try and test, before actual buying. So you can contact me anytime. And with that, thank you so much. If any questions, Anil, over to you.
Yeah, thanks, Prerna. I think there are some questions that have come in. I'd request, if we can now just do a Q&A and have Anish also on the screen, because there is quite a few questions that have come in from the attendees while, the session was happening. So Anish, several people have requested you to explain the data science slide once more, about, I think it's around the skill set or something, the data science skill slide. So if you could just explain that quickly, briefly.
Sure. Let me share my screen once again.
Guys, can you do that? Admin, yeah.
Okay. Yeah, Anil, is it visible?
Yes, yes.
So basically, what we are saying is the data science, right, is more evolved in a way than pure data analytics. Data analytics is more descriptive in nature, which requires either understanding just the data, and basically you need DBMS kind of skills, or you need business intelligence or visualization kind of tool skills, right? Which is your Tableau, Power BI and all, right? Along with that, in data analytics, you would need certain skills which are common to data science, like your programming languages, problem solving, storytelling, etc. Right? So these are common skills. So we are only focused on the right-hand side now, right? But when you come to data science, apart from programming skills, which are like Python or data mining or storytelling, what you also need, where a lot of work is happening in data science, is more on the machine learning side or predictive analytics side, right? In fact, what Prerna showed just 5 minutes back helps you understand this slide even more. She had one page which talked about all the ML AI libraries, right? Whether it was XGBoost or TensorFlow and so on, right? And then there were programming languages and so on. All this thing is part of your machine learning part in data science, right? Right. And then there are certain skills required to manage big data, right? Like a lot of companies use Hadoop or Spark, right? How do you manage the big data is slightly different than how do you manage structured data through simple RDBMS, right? So that is primarily the difference between the data science skills and the data analytics skills. Right? It's a journey, it is an evolution. Doesn't mean that somebody who started off in data analytics can't do data science. He or she can, but if they want to do, they need to just upgrade themselves through some of these things which are on the left-hand side of the circle.
Yeah, thanks, Anish. I think good, well explained, because you need the right side. I mean, if you want to do data science, you anyways have to have the things on the right side. That is data analytics. If you want to really be able to do data science, it's much more than just the basic things that you mentioned on the right side for data analytics.
Yes.
Okay.
Yes.
Great.
I will stop sharing.
Yeah. So a question to Prerna. So does ZBook series notebook, have compatibility with applications like, Adobe, Creative Cloud, PTC, Creo, and Photoshop kind of applications?
Yes, definitely. And with a lot of these software vendors, we already have, tested specifically for these softwares and workflows, the ZBook series. So to answer your question, yes.
Okay, great, thanks. So Anish, further on the skill set part only, somebody wants to know if they can move into data science technology, after having spent, say, a significant amount of time, 20 years or so in the ERP domain. Can they move into data science technology?
See, simple answer is yes, right? There's nothing stopping you. Learning, I think even if somebody is a doctor, he can learn data science, right? It's not about learning, right? It's no rocket science, end of the day, right? Logical reasoning, some knowledge of programming. If somebody is in ERP, definitely that person would have done Oracle, some programming that person would have done, let's say, right? The challenge which I see is people being able to make career shift. That is more challenging, right? Learning is not challenging. So the most relevant, what I have seen people making a career transition is if their own companies where they are working has something new started on data science side. That is the best place to make a shift. Otherwise, in my own experience, it becomes difficult for people after considerable amount of work experience to make a shift, right? And then there are very obvious reasons, and there are many reasons for that, right? It's generally a question of fitment, basically. Just generally a question of fitment. It's never a question of whether somebody can do a role or not.
Right.
And I just want to add to what Anish said, right? So definitely it's not a rocket science, and making a transition within your company is always going to be easier. But where any person who has worked for the last 15 to 20 years can show value that, why I make sense for a data science role is that domain in which they have worked, right? If it is ERP, what kind of, domain they have worked on. So because that subject matter expert, that domain expertise is also very, very essential. And as in, how we are going and these software SaaS companies are evolving, they're coming up with a lot of tools and technologies wherein actual, the domain expertise becomes more essential, I think.
It's a great point. It reinforces what I shared in terms of the core part of the cycle is the business understanding, right? So it's a great point, Prerna.
Yeah, and also Prerna, just coming back on the point about the systems and all that. Although you showed so many systems from Z, but is there a particular criteria that should be followed for choosing a system for AI and data science? Just to take the discussion point a little further, what would be the advantage of using a workstation over a regular system for data science? I mean, can't the regular one also do the same thing if it's powerful enough?
Right. So I would like to answer this question that, if I want to go from Kashmir to Kanyakumari, do I need to take a flight, right? Can't I go by train or something like that, right? So it actually depends on your workflow, what kind of data you are working on, how massive is the data, how complex is the data, what sort of models you want to run on it. It really depends on that. So if it's let's say it's a tabular form of data, 200 rows of data, I can very well run on my normal machine. The 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 change you will see when you will see in the modeling time or the time it takes to train your model. There you will see a lot of improvement and efficiency. So I think it depends is my answer.
Yeah. Okay. So it depends on what kind of requirement is there, what sort of, if you're really doing a lot of modeling, then probably.
Yeah, if it, right, if it's a use case where there is data crunching, so there is going to be efficiency, there's going to be productivity. The amount of training, if it was requiring, let's say weeks earlier, it will now take hours to do that. Okay. So that is the advantage.
Okay, that's a huge advantage actually.
Definitely.
2 hours. And that last slide you showed about NASA, that itself also explains it.
Yeah.
Yeah. Anish, I mean, you referred to a lot of structured data, unstructured data also that is coming in, and we all agree that data is coming from multiple sources. So of course the question is that is it like now a huge challenge to get information from multiple sources to make it really meaningful? What are your comments around that? To be able to get data from multiple sources, what are the challenges in doing that if you want to apply data science to it?
See, the short answer is it is difficult. It is not difficult to assimilate internally. It is difficult to get data because of 2-3 things, right, which are happening in the overall industry or set of industries, right? One is the strong data privacy rules, right? The GDPR came in, then, India also has not a lot of strict rules about data, right? Earlier, people used to scrape a lot of data from public sources, right? So that is stopping, right? That is one trend, right? We have to be mindful. It's becoming difficult to collate unstructured data. Second trend is a lot of people from where you can get unstructured data, they themselves have become huge users and sellers of data, right? So let's say it's not easy to get data from companies like Facebook, Google, right? Because they themselves are mining the data and are able to create better products than most companies are selling them, right? So if I now go to Google and say, hey, I want this kind of data for me to enhance my knowledge about my customers and do my customer management better, more often than not, they will not give, right? They will not get into any structured deal for that, right? That's the reason, right? It is easier to get data from data vendors who are doing some kind of work in the globe, in the world, collating those kind of data and then sell those data. That's a lot easier, right? There's a lot of intermediaries which are working in this field, right? But it's not. But as I said, the short answer is yes, it is difficult.
Yeah, thanks, Anish. Absolutely, it's not an easy job to be able to get data from all those sources, which is where data science comes in, and all those skill sets that you mentioned and the additional tools like Hadoop and all that come in, which are really required to be able to, collate all this data and analyze it and, bring out insights. So, well, I think we are out of time, and but there are many questions. What we'll probably do is, Anish, maybe I'll mail them across to you. And if you have some time, you can just give quick short answers to some of those questions. So my apologies, but as it is, we have reached end of time, so we'll have to conclude the webinar now. Thanks a lot, Anish. Thanks a lot, Prerna, for sparing your valuable time and coming and giving these insights and doing this Q&A. I really enjoyed, this conversation a lot. I'm sure that the attendees also found it useful. And for the attendees, we'll also put up the announcement about who have won the Amazon gift vouchers on the microsite, like we've done in the past series. Before you leave, I'd request you to fill up a feedback form to tell us how you found the session. I think we've already posted in the chat window in front of you. So do share your feedback. Let us know how you found it. And thanks a lot for joining in and being so interactive, giving us all those great questions. I think it was really, really great to have this discussion. So thanks to everyone. Thanks, and stay safe, stay healthy. Have a great weekend, guys. It's been really great. So thank you once again. Thanks, Anish. Thanks,
Thank you, Anil. Thanks.
Thank you. Thank you so much.
Yeah. Bye-bye. Have a great evening and a great weekend. Take care.